Hello everybody, today I can perform line reflections by counting to the line I'm reflecting over. So we're going to reflect over a lot of different types of lines here. We already learned how to graph straight lines, so that is going to definitely come into play here, so make sure you know how to graph a straight line. Let's go. Triangle sun, that's the same example that we've been working with for other things, but now we're going to do a reflection with it. Triangle sun has coordinates S 0, 6, U 3, 5, N 3, 0, and it wants me to reflect it over the x-axis. So to reflect over a line, count to the line I'm reflecting over. So if I'm reflecting over the x-axis, I'm going to take each point and I'm going to count to that line. So let's start with S. To get from S to the line of reflection, I'm going down 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Whatever I do to get to the line of reflection, do the same thing through to the other side. U, down 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now N is on the line of reflection. If it's 0 from the line of reflection, then it goes 0. When a point stays where it is, there is a name for this. It's called invariant. It means that the point doesn't move. So if a point is on the line of reflection, it will remain invariant. It will stay where it is. There you go. That's how I do my reflection. This one does state the coordinates. If it says to state the coordinates, state the coordinates. If it doesn't, then you don't have to.
Good morning.
So S prime, I've got 0, -6. U prime, I've got 3, 5. N prime, I've got 3, 0. Y-axis is going to be the same thing, but now I'm going to count to the y-axis. So I've got A is 3, 1. I've got B is 0, 4. I've got C is -5, 3. And I want to reflect this over the y-axis because it tells me it wants me to reflect it over the y-axis. Not the best straight line there, but whatevs. So now I'm going to count from each point to the line of reflection. Let's start with C. To get to C to that red line, I'm going 1, 2, 3, 4, 5 to the right. So I go 1, 2, 3, 4, 5 to the right. That's going to be C prime. For A, I need to go to the left. 1, 2, 3 to the left. So I go 1, 2, 3 more to the left. B is on the line of reflection, so as we said in the last example, it stays where it is. That's called invariant. I connect them. I'm done. It doesn't say to state the coordinates, so I'm going to save some time and not state the coordinates. Number 3, I've got graph that's too big. Let's get a little bit smaller. I've got A 2, 1. I've got B 6, 1. I've got C 5, 3. I want to reflect over x equals 4. Well, if you don't know what x equals 4 is, you're not going to be able to do this. I need to start by graphing x equals 4. Remember, Yancey has X-ray vision. If it's y equals a number, it's a horizontal line. And if it's x equals a number, then it's a vertical line. So x equals a number is a vertical line. So I go to 1, 2, 3, 4 on the x-axis, and I make a vertical line. So now I do the same thing that I did before with the x-axis and y-axis. I count to the line I'm reflecting over, which in this case is that blue line. So A, if I go 2 to the right, I go 2 more to the right. It actually landed on B. And B, I would go 2 to the left. So I go 2 more to the left. That happens to land on A. C, I would go 1 to the left to get to the line of reflection, so I go 1 more. That's your C prime, and that's it. So it's the same thing. It's just you have to graph the line of reflection. If the line of reflection is not there, you're not going to be able to do it. So you need to know what x equals and y equals a number looks like. So for number 4, we've got r is negative 2, 3. We've got s is 4, 4. We've got t is 2, negative 2. It wants me to reflect over y equals negative 2. Yancey has X-ray vision. It's horizontal. So I go to negative 2 on the y-axis, and that's the line I'm reflecting over. So now I need to count to the line I'm reflecting over. I'll start with R. To get from R to that line, I go down 1, 2, 3, 4, 5. So go down another 1, 2, 3, 4, 5. That's R prime, S prime, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's S prime. T is on the line of reflection, so it remains invariant. It stays where it is. I connect them. I'm done. There's one more example, one more thing to know about reflections. If we go to number 11, y equals x. I want to make this very simple for you. Yes, we can do this on the grid, but for y equals x, there's a rule I want you to know. When you reflect over y equals x, you switch the order of the coordinates. So I don't even need the grid for this one. And yes, there are other rules for some of the other reflections, but I'd rather you just do them on the grid. Y equals x is different because it's the slope line, so it can get a little bit trickier. So the easiest way to do y equals x, again, is to just switch the coordinates. It's not something that comes up that much, or else I'd focus on it more. So if I start with negative 4, comma 1, switching the points would make it 1, comma negative 4. The order's changing, nothing is being negated. Negative 2, 6 becomes 6, negative 2, and 5, negative 2 becomes negative 2, 5. That's your S prime, B prime, and R prime. Again, I just switched the order of the coordinates for each. It did ask me to graph it, so I guess I should quickly get them on the graph. S, B, R is 5, negative 2. And then S prime, B prime is 6, negative 2. And R prime is negative 2, 5. And if you're wondering what y equals x is, which you should have learned back in Algebra 1, it is a line that goes through the origin and has a slope of 1. So if I do draw it in, you should be able to see that if I kind of turn my head and I fold it over that line, it will land on itself. So for y equals x, just switch the coordinates. Otherwise, count to the line you're reflecting over. If you're reflecting over the x-axis, count to the x-axis. If you're reflecting over the y-axis, count to the y-axis. If you are reflecting over an x equals a number or y equals a number, you need to graph them first. X equals a number is a vertical line, y equals a number is a horizontal line. And if you're not comfortable with that, then watch the lesson on that. That's all I got for you. Practice, and have a nice day.